Welcome to Escape Velocity Space News. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. This is episode 20 of our 22-episode season. This doesn't mean we're going away for the summer. It means we're going to be providing you more chances to meet us face to face. In fact, our producer Allie and I will be at Balticon in Baltimore, Maryland, Memorial Day weekend, and we'll be doing a CosmoQuest meetup May 24th. The details are all in a public post over on patreon.com/CosmoQuestX. There's also an RSVP poll, so let us know if you can come. And check it all out, and the meetup in Baltimore is just the start of what we have planned. There will also be an event in Orlando on May 30th, and there may be an event in Madison, Wisconsin on June 10th. We are also looking for a date the last week of August in Orlando. To find out about all of this and more, join our newsletter at cosmoquest.org. And until we meet in person, there will be science online. This week, we have news about merging stars, massive black holes, and the incredible geology on Jupiter's moon Io. All this and more is coming to you right here, right now on EVSN, a product of CosmoQuestX. Please give this video a like and a subscribe to get more science delivered to your feed. In the southern sky, about 3,800 light-years away toward the constellation Norma, the well-named Dragon's Egg Nebula has been hiding a secret. Surrounded by a cloud of carbon, nitrogen, and oxygen are a pair of mismatched stars. Despite forming from the same original material, these stars have very different chemistry. And that just shouldn't be possible. It's like somehow getting one double chocolate cookie and a pack of regular cookies. Something had to happen. And the clue to what happened is in the stunning nebula that surrounds these stars. It is made of materials not generally shed from stars. That carbon, nitrogen, and oxygen that it contains is generally locked away inside stellar cores. According to a new paper published in the journal Science with lead author Abigail Frost, this system formed with 3 sibling stars. But at some point in their past, one of the siblings, much like a shark, woke up and chose violence and ate its sibling. It wasn't neat either. That surrounding material is the leftover guts of the consumed star. As described by researcher Hoygs Sana, quote, "The 2 inner stars merged in a violent manner, creating a magnetic star and throwing out some material which created the nebula. The more distant star formed a new orbit with the newly merged, now magnetic star, creating the binary we see today at the center of the nebula." There are lots of reasons for a star to eat another star. In terms of science, the reason is pretty simple. Gravity can and will draw 2 stars together if the stars are aligned just right. But to continue our anthropomorphizing of these great balls of plasma, the consumption of the companions can make a star look significantly younger. In fact, the cannibal star appears 1.5 million years younger than its remaining sibling. This kind of a merger also grants the remaining star a powerful magnetic field, a feature not otherwise found in large stars like this one. Remarkably, researchers are able to determine when this siblicide took place. The mix of elements in the nebula indicates it's only 7,500 years old. If you're in the southern hemisphere, This object can be readily observed with a 16-inch telescope. To replicate this research, however, you're gonna need the amazing spectrometers on the Very Large Telescope and 9 years worth of data. The universe we see doesn't always reflect the universe that is out there. Luckily for us, a lot of dark details can't stay hidden for long because their motion gives them away. The Gaia spacecraft was launched in 2013 on a mission to measure the precise locations of every point and smudge of light visible to its weird rectangular mirrors. With the ability to see motions across the sky that are just fractions of a hair's width in size, it has been able to see stars and binary systems move in their orbits. And it has seen more than a few stars moving with no visible companion. And one of these lone points of light is moving in a way consistent with the presence of a 33 solar mass black hole failing to shine as its partner. This star, the visible one, a 0.76 solar mass elder giant, is on a nearly 12-year orbit around something that has nearly 33 masses of material, something that isn't giving off light. And a black hole fits the bill. The elder star is very low on heavy elements, and a low metallicity star like this has the potential to start out very, very large. It's possible that what we're seeing was once a binary system with a small star and a star of unusual size. While the smaller is still there and still evolving very slowly, the larger could have lived and died and formed a black hole that we're now failing to see except through its gravitational pull. It's also possible that there is a pair of black holes that are smaller, or maybe even a black hole and a neutron star that is beyond the abilities of Gaia to see. Hopefully, follow-up data will be able to better constrain what dark monster is pulling around the one visible star. For now, there's the potential that Gaia has found the new record holder for largest stellar black hole. Our universe is a dynamic place. We're on a planet that is rotating and revolving around a star that's orbiting around a galaxy, and our sun is evolving and blasting out a solar wind, and we trail particles and sometimes even asteroids and comets behind in our solar system's passage. We are a messy solar system, and scientists have been actively looking to see if other stars make similar messes of their surroundings. Thanks to a new paper appearing in Nature Astronomy and led by Kristana Kristlakova, we can now say yes, other stars do have stellar winds like our sun, and they can even be more powerful than our suns. Using the XMM Newton X-ray Observatory, researchers looked at the sun-like stars in 70 Ophiuchi, Epsilon Eridani, and 61 Cygni to see if they could detect the X-ray emissions that would be triggered by particles in the stellar wind interacting with the interstellar medium. Sure enough, all these systems had the predicted emissions, and the emissions were actually stronger than expected. It's as if there's an added kick that is driven by these stars having stronger magnetic fields. For your amusement, the sun-like star in Epsilon Eridani is linked to Vulcan in Star Trek lore. This means if you want a more nuanced view, Vulcan would potentially have more aurorae than Earth, and it would be getting blasted by more powerful solar winds hitting its atmosphere. To maintain an atmosphere and life, it would have to have a large magnetic field. May your fiction always come with a side of really cool science. Up next, we're just going to spend a segment oohing and awing over Io's amazing volcanoes. Stay tuned. In Roman mythology, Jupiter is not exactly a faithful god. There are some that would allege him willing to bed just about anything, and this tendency shows up in some really funny ways in how we name things. Jupiter's 4 largest moons, for instance, are named Io, Europa, Ganymede, and Callisto after 2 mortal women, a beautiful prince, and a nymph, who Jupiter had dalliances with. Basically, since the time of Galileo 400 years ago, the planet Jupiter has been condemned to be chased around forever after by 4 of his lovers. And then, in an act that continues to amuse me, NASA launched a mission called Juno, named after the Roman goddess who was Jupiter's wife, and they sent Juno to explore Jupiter and his moons. This means, for the past several years, as part of Juno's extended mission, the namesake of Jupiter's wife has been sidling up to the moons named after his lovers, exploring them with her cameras, and then continuing on. Well, unable to visit all the Galilean moons, Juno has made a series of passes by Ganymede, Europa, and most recently Io. In February, on its closest approach, Juno was within 930 miles of Io's surface. Since then, Juno's orbit has been shrinking, bringing the mission in closer to Jupiter and away from those circling moons. Put simply, Io and Juno have parted ways, and Juno is now snuggling down into a tighter orbit around her Jupiter. In the months since that final closest approach, researchers, professional and volunteer citizen scientists, have been poring over the images and other data from Juno to learn all they can about this amazingly volcanic world. In this segment, we're going to take you on a quick tour through our favorite new discoveries. Thanks to the amazing imagery from Voyager 1, we've known since 1979 that Io has active volcanism. As telescopes on Earth have gotten bigger, we've struggled to make out hot spots and other telltale signs of eruptions from our location at least 365 million miles away. And while this has been enough to keep track of some features, it just isn't as satisfying as getting an up-close look. Enter Juno. Launched in 2011, this little mission arrived at Jupiter in 2016 on what was intended to be a roughly 3-year science plan. Its amazing success, however, earned Juno a mission extension, and during this bonus round of science, the mission team has been maneuvering Juno on ever-shrinking orbits that have allowed it to spend about a year flying past each of the 3 inner Galilean moons. 2023 and heading into 2024 was the year of Io. In the lead up to this year of encounters, Juno brought us an IR image that reminds us just how many active volcanoes coat this world. Taken from 50,000 miles away, this image makes it clear Io is a place of lava and brimstone, the kind of world where Darth Vader might feel right at home. The flyby started in earnest in December 2022 and teased us with what was yet to come. In the first encounter, we got a sense of the geologic and mineralogic diversity of Io's surface, as we saw expanses of different colors and clear evidence of different textures. Things weren't much better when we saw Io in May 2023. It was just still vague texture and color. But at least we were getting a different perspective with every pass, allowing us to see more and more of Io's surface. It was the July 2023 flyby, which brought Juno within 13,700 miles, that brought us the science many of us were most watching for. In these images, volcanoes previously observed by Galileo in 1996 and New Horizons in 2007 were seen one more time. According to team researcher Jason Perry, quote, "When I compared it to visible light images taken at the same area during Galileo and New Horizons flybys in 1999 and 2007, I was excited to see changes at Volund, where the lava flow field had expanded to the west and another volcano just north of Volund had fresh lava flows surrounding it. Io is known for its extreme volcanic activity, but after 16 years, it's so nice to see these changes up close again." End quote. Io's active volcanism was highlighted again in October 2023 when images of a quarter-phased Io contained a bright eruption shining from the night side of the world. Juno had caught Prometheus volcano ejecting a plume of material. With each flyby, we saw more. The December 30 and February 3 flybys brought Juno within 930 miles of Io's surface. Illuminated by the sun on one side and light reflected off Jupiter on the other, these views gave us a full disk image that revealed mountains and even a lava lake with mountains rising from its surface. A couple months later, the mission team has now had a chance to dig into the data and pull out some of the details. In April, they released some amazing video. While lots of folks are going over the active volcanoes, what caught my attention is a steeple mountain, a razor blade of a mountain that is 3 to 4.3 miles in height. For comparison, Mount Everest is 5.5 miles in height. Also defying expectations, one of Io's most famous volcanoes, Loki Patera, is now associated with a roughly 130-mile-long lava lake that contains, according to principal investigator Scott Bolton, quote, crazy islands embedded in the middle of a potentially magma lake rimmed with hot lava. The spectacular reflection our instruments recorded off the lake suggests parts of Io's surface are as smooth as glass, reminiscent of volcanically created obsidian glass on Earth. End quote. To be honest, this is just what was obvious in the images, and it isn't even all that was standing out demanding researchers' attention. It will take months and even years to get all possible science out of this data. And when those results come out, we will bring them to you right here on Escape Velocity Space News. Up next, I'll be joined by Erik Madaus as we take a look at all the latest tales from the launch pad. Stay tuned. Up next, I'm pleased to welcome on aerospace correspondent Erik Madaus for this week's Tales from the Launch Pad. Hey, Erik.
On April 15th, China launched the SuperView Neo-3-1 satellite for China's UA Survey and Mapping Technology Co., a state-owned remote sensing company. The half-ton satellite was launched into orbit on Long March 2D. The satellite has 130-kilometer swath width and a resolution of half a kilometer per pixel. 15 more SuperView Neo-3 satellites will join this one in orbit. There were also 3 launches of Starlink satellites. Before we get to this week's stats, we have an update on an event earlier this year. On February 28th, 2 satellites, NASA's timed and a derelict Soviet reconnaissance satellite, Cosmos 2221, came closer to each other than anyone was comfortable with. Commercial satellite tracker Leo Labs initially predicted a separation of 20 meters and an 8% chance of collision between the 2 satellites, neither of which could have adjusted orbits to avoid the other. Luckily, they did not hit, as that could have been catastrophic for satellites in low Earth orbit, sending a shotgun blast of debris across orbits at that altitude and lower, which includes the International Space Station and Tiangong Space Station. NASA recently reviewed the orbital parameters of the conjunction and revised the estimated closest approach to just 10 meters. That's incredibly close. For reference, timed is 11.7 meters wide with its solar panels. Numerous close calls have been recorded in recent years. It's a matter of time before a collision actually happens. We keep track of launches with the help of RocketLaunch.live. So far this year, the United States have had 44 launches, China has had 17 launches, Japan, New Zealand, Kazakhstan, and Russia each have had 3 launches, India and Iran each have had 2 launches. This makes the total number of launches so far this year 77, with 2 failures. Finally, there are 10 toilets in space.
Thanks, Erik. Before we go, I want to remind you that sometimes the coolest research comes from the cutest of inspirations. While researching a book on galaxies, Orr Grauer took his daughters to a museum where they were enchanted by an Egyptian image of an arched woman bent through the sky. The painting depicted the Egyptian god Nut, arching over her brother, the earth god Jed. As the story goes, the daughters kept asking to hear stories about this woman bent through the sky. And according to Grauer, quote, this sparked my interest, and I decided to combine both astronomy and Egyptology to do a double analysis, astronomical and cross-cultural, of the sky goddess Nut, and whether she could be linked to the Milky Way. End quote. His analysis appears in a new paper in the Journal of Astronomical History and Heritage, where Grauer argues, quote, that the summer and winter orientations of the Milky Way could be construed as figurative markers of Nut's torso or backbone and her arms, end quote, and shows that, quote, Nut's roles in the afterlife and the autumn bird migration are consistent with similar roles attributed to the Milky Way by other cultures. And Nut's identification with the Milky Way may even have echoes in contemporary African conceptions of the galaxy. End quote. This is an amazing case of the Milky Way, rather than a constellation of individual stars, being seen as a figure in its own right. This research also shows how ideas can spread vast distances across our world. Next time a kid asks a cool question you and no one else know the answer to, it might just be time to hit the books and learn something amazing. And that's it for now. Good night, everyone. And remember to go out and look up. Oh, and just to say it again, please give this video a like and a subscribe so the algorithm tells you and the world when new science is ready to be learned. Thanks.